Okay, I'm going to be performing a simple experiment to see if the Captret is affecting the plus and negative of the capacitor. So basically what I'm going to be doing is taking this lead and shorting it out on the Captret part. Alright, so the basic setup is a 2.3 volt 10 farad supercapacitor. Alright, I got hooked up. The big red lead part of my meter connected up. And the black lead goes there to that probe and hooked up like so on the negative of the capacitor. You see the negative line right there. Basically just hooked up. And if you hook up any capacitor to a meter, the internal resistance of the meter will drop the capacitor's voltage. Yep, drop it down just like so. There you go. So you can get about a good estimate of how fast it's draining with just a meter connected. So with just a simple experiment, I'm going to dead short. There's going to be no LED or anything. Dead short the positive. This cable positive, or this cable to the top of the Captret, which is the metal part right there. While you guys watch the voltage. Tapping it right now. So it's 1843. Yep, hasn't moved. I've been dead shorting it. Let's see, 1842. When I say 1842, I mean 1.842. It's just easier to say 1842. So I'm dead shorting, and I'm pretty sure that's not going to satisfy with most people. So the reason why I didn't hook up the black lead like I did with the red lead, because now I can do this. Disconnect that. So the meter is reading 0 voltage. I'm going to see what's inside the Captret part itself. And that's what's inside the Captret part. Now we're going to dead short it like we did before. And that's what's in it now. So there's been a loss in the Captret part, but there's not been any loss in the capacitor part except the loss that's from the meter itself. So there you go. What we have here is that the Captret does not drain the power that's inside the capacitor's main leads itself. So there you go.